Problem 9. We basically want to simplify this trinomial over the binomial and see what we get. Basically n plus 5 into n squared plus 7n plus 10. When I look at this, the first thing that comes to mind is, hey, the top can be factored. Let's factor it. I got things of 10, so I know that it's either a 1 and a 10 or a 2 and a 5. Well, what's going to create the 7n? That's the 2 and the 5. Goes back to basic algebra. So this is going to break down to an n plus 2 times an n plus 5. Notice n times n is n squared. The middle piece 2n, the outer 5n, that gives you your 7n, and 2 times 5 is 10. And again, I just simply took 10 and I said, hey, factors of 10 are 1 and 10, 2 times 5, that's what would create the 10. And what added together creates the 7n? Oh, that's the 2 and the 5. That's how I knew it had to be the 2 and the 5 there. Now, all this is over n plus 5. We don't know what n is, but here's what I do know. Let's say n is 4. This would be a 9 right here, and this would be a 9, and they would cancel out with one another. So I can see that no matter what n is, this guy and this guy are going to cancel. So our answer is this just simplifies to an n plus 2. And we think that we're all done. But we need to clarify something for people. We need to come back and make a statement. Notice the n plus 5 canceled out. You think that, oh, this is the exact same as this. And it is, except for we got to make one note. We got to tell people that the one thing n cannot be. Well, look back at the original problem. What value, if you try to plug in for n, would create a problem here? Well, if n is a negative 5 right here, negative 5 plus 5 creates a 0 on the bottom, and you can't have that. So we've got to make sure that we tell people this does simplify to just n plus 2, but n cannot be a negative 5. We've got to make a side note here saying this simplifies n plus 2, however, make sure n can never be negative 5. People might say, oh, why can't it? I'll plug negative 5 in there and get negative 3. Yes, but again, we're saying, what about back here? This can't have a negative 5 in it, and we've crossed that out along the way, so we need to make note that n can't be negative 5. Please, again, would you rather have to plug in up here or here? Let's say that you plug 10 in. Well, you and I can quickly say, oh, if you plug 10 in, you're going to get 12. Notice we'd get the same thing up here. If you plug 10 in, that's going to be 100 plus 70 plus 10, all divided by 15. Well, that's 180 divided by 15. And 180 divided by 15, guess what it is? It's 12. Well, I'd much rather plug 10 in here than in that equation there. That's why we simplify it, to get it to be simpler so that we can plug in a number and get an answer very quickly. But we had to make the note that you're not allowed to plug negative 5 in because it wouldn't work in the original equation. So we got to make a statement there to say, hey, this is what simplifies to, but don't you let it be negative 5. There you have it.